Hello, my name is Kelly Albus, and I am with Texas A&M AgriLife Research and the Texas Water Resources Institute. And we are excited to present our project to you today about volunteer monitoring of optical brighteners in Texas waterways. We are sharing this in the form of 2 story maps today. So we are moving through this content pretty quickly for the presentation, but please feel free to go back and check out those story maps. They're online and public, so the links will be in our session page information. We are going to be team presenting this presentation today, and our first presenter is going to be Desiree Jackson from the Texas State University and the Meadows Center for Water and the Environment, and she's going to be talking about some of her graduate research that she did as part of this project.
Research shows that community scientists' volunteer monitoring can serve to fill data gaps, engage volunteer community scientists, especially in underserved geographic areas, and in turn, these individuals can ultimately serve as advocates for change. This was the outcome of the work presented here, and we are so excited to share our experience with you. This work took place in the Cypress Creek watershed in the central Texas Hill Country and encompasses the cities of Wimberley and Wood Creek. This area has undergone and continues to undergo lots of growth and development. According to the Texas Association of Counties, Hays County is one of the 3 fastest growing counties in Texas and is also among one of the top U.S. counties experiencing intensified population growth. The unique karst geology in the area is comprised of cavernous limestone rock that can serve as a conduit for non-point source pollution during rainfall events. The watershed spans some 38 square miles and has no permitted point source discharges. The commercial and residential properties in the watershed have historically been served by on-site septic systems for wastewater disposal. The watershed transitions from a rural landscape in the headwaters, primarily comprised of forest, shrub, grasslands, and open space, to a more urban setting towards the outlet, where most of the developed land use is located. Much of the natural landscape supports native wildlife such as deer, hogs, waterfowl, and other mammalian wildlife, including bats. A land use change analysis revealed an increase of approximately 1 square mile of aggregated developed land use between 2011 and 2019. Subsequently, the lower portion of the watershed is where quarterly Clean Rivers Program monitoring data since September of 2016 shows consistent exceedances of the E. coli bacteria water quality standard for the contact recreation use, specifically below the Ranch Road 12 bridge near the Wimberley Town Square. Results of that data prompted the current study in the lower 1 mile reach of Cypress Creek, a perennial freshwater spring-fed stream. The study had 3 main objectives. First, monitor E. coli bacteria to identify potential sources of contamination. Second, conduct optical brightener tampling monitoring as a pollution screening tool. And third, develop a statewide citizen science prototype to serve as a warning system for wastewater contamination. We sampled 9 sites at varying frequencies from June of 2021 to December of 2022. Monitoring types included water quality field measurements, E. coli bacteria colony counts, and optical brightener tampling and fluorometric analysis. Monitoring methods implemented by the Texas Stream Team community scientists were used for field measurements and bacteria colony counts. Optical brightener tampling was conducted using methods developed by Kelly Albus 2021, and fluorometric analysis and exposure experiments were modeled after Chow and others 2009 and Hartel and others 2007.
Hello again, this is Sandra Arismendes, and I'll be presenting the results of our work today. So the results for the E. coli bacteria in this figure are organized from upstream to downstream, with the spring and the Ozona Creek tributary results shown towards the right side of the graph. Bacteria geometric means at sites downstream of the Ranch Road 12 bridge, which is noted there on the graph, were higher than the water quality standard as compared to those 2 sites that are located upstream of the Ranch Road 12 bridge. The highest values observed were at the Ozona Creek tributary. Monthly temporal analysis of precipitation and E. coli geometric means for all sites combined for the entire period of record showed higher overall precipitation values in 2021 than in 2022, as noted by the red dashed line on the graph. but lower overall E. coli geometric means were calculated in 2021 than in 2022. Also note that E. coli values peaked in October for both years, just before the bat colony migrated southward upon the arrival of the cold fronts that moved through the area in the fall and winter. A correlation analysis of monthly E. coli geometric means and mean precipitation by year revealed a positive and significant correlation during the wet year in 2021 as compared to the drier year in 2022. Laboratory fluorometry measurements were conducted before and after water samples were exposed to ultraviolet light for 5 and 10-minute intervals. This experiment was designed to discern optical brightener fluorescence from organic matter fluorescence. If water samples contained optical brighteners, then the ultraviolet light exposure would allow them to photodecay. The 5-minute exposure experiment revealed mean percent differences greater than or equal to 36%, while the mean percent differences greater than or equal to 45% were measured at all sites after the 10-minute exposures. These results support the presence of optical brightener photodecay at all sites. This graph shows a positive and significant correlation resulted between E. coli bacteria and fluorescence for all sites combined. These results further support the hypothesis that optical brighteners can be used as a tracer of septic system contamination, and that septic systems are a likely source of E. coli bacteria to Cypress Creek. The tampling method was employed as an inexpensive preliminary pollution screening tool to discern the presence or absence of optical brighteners as indicators of fecal contamination from septic systems. Optical brightener fluorescence was detected at all sites and for all deployments. Therefore, this method, alongside the fluorometry measurements, proved to be a viable screening approach for detecting the presence of optical brighteners.
As Sandra and Desiree explained, the optical brighteners and the tampling both turned out to be viable ways for detection of human sewage contamination in the stormwater infrastructure systems, which can be really crucial to a place that's experiencing transition from a primarily rural use to a primarily urban use. And these was a really exciting finding, but one of the main reasons that we started out using this particular method was because of the low cost, how all of the supplies were very accessible, and also the results were very visual and really directly connected to human impacts on waterways, which is some of the educational messages that we are trying to share with schools. And so we really wanted to provide a comprehensive set of tools to reach out to communities to show them how they can participate in ongoing research through these low-cost accessible tools. One of the ways that we did that was through social media. So we ended up on a lot of different platforms: Instagram, Facebook, Twitter, YouTube, TikTok, and we wanted to try to show people not only could they get involved with water resources, but also they had a voice and a way for sharing whatever they find. And so this is an example of one of the videos that we made. So after releasing videos and online content through social media, we also wanted to make a more targeted effort to educate community members, especially in the surrounding area from our Cypress Creek study, because not only is there a school right nearby, but there is also a very interested and active community in the region that we thought would be a fantastic pilot for our community outreach efforts. And so we made a series of materials and tools for teachers that were based on Texas state standards. And they also included all of the supplies and materials needed for students and teachers to conduct their own research in waterways in their communities. This was done through grants from the National Geographic Society and the Texas State Soil and Water Conservation Board. And we were able to provide sampling toolkits for our teachers for them to go and conduct their own experiments after the training. This is an example of one of the samples that was collected by one of our students. This is teachers doing macroinvertebrate sampling, because we also combined other water quality monitoring techniques along with the sampling so that teachers could try a series of activities with their students. This was an example of our teachers. They went to a street or a park across the street from their school and were able to do some sampling in that stream and did actually find a positive result. And then here is a example of us reading the tampons with the teachers in the classroom. And you can see this is another very positive result. It's glowing very bright blue under the black light. And here are some of our tampon samples that were put away for storage. So through this hands-on place-based activity, teachers and students were able to take action in their local waterways right away. And through citizen science, we were able to capture that data and share it publicly through story maps and maps, which we'll talk about a little bit more later. This was very inspiring for our students and our teachers. It helped them feel like that not only did they understand what was happening to their water, they were able to take part in it and have a voice. And in fact, this inspired some of our students to create some of their own videos about water and issues in their community. And this is one of our favorite videos that was created by some 8th graders that are right on Cypress Creek. And so I'm going to play their video for you so you can see how this project has gotten students thinking about water in their community.
Cypress Creek used to be filled with bright vegetation and cool water before we started draining the aquifer.
Don't worry though, because there is a solution. I'm standing in front of Blue Hole Primary, which is Texas's first school with a one-water system. A one-water system is when they use the collected rainwater or storm runoff, filter it and treat it, and then put it into things like the sinks, bathrooms, and water fountains, which would otherwise be draining the aquifer.
This right here is Blue Hole Primary's rainwater harvesting tank.
Here's some real-life examples of how one-water systems can cut costs in schools. Our school pays $11,000 a month for water services, while Blue Hole only pays $700. Now, we understand that one-water systems can be expensive and difficult to install, almost as difficult as it was for me to get in this tree. But they'll save you so much money in the long run and a whole lot of water. You can even get tax write-offs or grants for installing the systems.
Thank you so much for watching our presentation.
And we hope this can bring us one step further to renewable water systems.
So this was very encouraging for us because not only were students able to understand the material being presented, but they were also able to take it and turn it into their own story and take a part or an active part in the management of water in their area. So we felt like we were really helping to empower teachers and students. And also this has led to more community support, including some of the local businesses agreeing to do dye studies to see if they're polluting the nearby river. And this is due in part to pressure from the community for change. So one of the ways for doing this is to not only involve them in the education aspect, but also to co-create management of water resources through citizen science. And in order to do that, we needed to create a very interactive platform for people to engage with the material and also with the data collection and the data visualization, so that when we share these results with city managers and professionals, they may actually lead to action. So I'm going to let our next presenter take that.
My name is Ben Hendrickson. I'm a PhD student in ecology at the University of North Texas. Here is a link to the sampling protocol designed by Dr. Albus. It is a Google sheet explaining all the materials and methods needed to do sampling yourself. Below that, we have a link to our Survey 123 sampling survey. This survey includes photo upload capabilities, geotagging capabilities, and mandatory questions. Below the sampling survey, we have the results from that sampling survey in the form of a live map. If you click on any of the points on this map, it will bring up the result from that point, including the optical brightener result, date and time when the sample was collected, any notes or photographs that the user might have uploaded at the time. Below that map, here's just a quick image of a graph of our results as of mid-2022. And below those results, we have our optical brightener resources, links to our video resources, including our social media channels, and below that, water quality resources.
Thank you, Ben. And this concludes our presentation today. We want to give a special thank you to our sponsors and contributors, especially the Texas State Soil and Water Conservation Board, National Geographic Society, who've been such great supporters of teacher education across the state, the Boroughs Welcome Fund, Dr. T. Wynn, and the Climate Change Agents, Taylor, Liz, and Talia, and Ben, for all of their fantastic work on the social media platforms and videos, and also Chase and Evelyn, Mrs. O'Gan, and all of her students from Danforth Junior High who have been very inspiring and just such great people to work with. So thank you all for your time today. And please feel free to go through any of these resources and reach out to us with any questions or just to talk about sampling. Thanks again.